Okay, let's recall a problem from the last lecture. Find the domain of f of x equals root x plus 2 times x plus 3 over x squared minus 4. Okay, in a problem like this, we learn to convert the problem of the domain to a problem of an inequality. Inequality, what is the restriction here? We must take what is inside the root and make it greater than or equal to 0. X plus 2, x plus 3 over x squared minus 4 all greater than or equal to 0. Now we converted the problem of finding the domain to a problem of solving an inequality. We need to solve this inequality to find the values of x which satisfy this inequality. Okay? Now we learned how to solve such an inequality. First, the first condition is that this side must be 0. Is it satisfied? Yes. The right hand side is 0. If I had any other thing in the right hand side, I should make it on the left hand side and make this side equal to 0. The second step is to make this function as brackets, all as brackets. Okay? I will just put another bracket here. X squared plus 1. Okay, so we need to put this expression all in brackets. Is there any possible factorization for this form? Yes, there is. Can you find it? Yes, this bracket can be factorized. So I will write it as x plus 2, x plus 3 all over x minus 2, x plus 2, x squared plus 1, all greater than or equal to 0. Okay? Now I may notice that there is a bracket that can be cancelled from the numerator and denominator. X plus 2 and x plus 2. Should I cancel it or not? No. In finding the domain, we do not cancel or we don't make any simplifications, because making simplifications changes the domain. Okay? So let's solve this inequality. How to solve this inequality? We learned that we need to find the zeros and the poles of this expression. What are the zeros? The zeros are the points of x or the values of x that make the numerator equal to 0. What are the zeros here? They are -2 and -3, which make the numerator equal to 0. What about the poles? The poles are the values of x which make the denominator equal to 0, which are x equals 2, x equals -2, and can this be 0? No, this can never be 0. So these are the poles and the zeros. What is the next step? I put all of these on the number line. Okay, we'll have here -2, -3 before it. Let's make it -3, -3, -2, and 2. Okay, what is the next step? The next step is to see if I have an equal sign, then the next step is to make the shading on the poles or the zeros that I have. Do I have an equal sign? Yes, I have an equal sign. So there is some shading that I will do. What is the shading? I shade all the zeros. I shade all the zeros except if there is a 0 that is also in the poles, because poles are never shaded. Poles are never shaded. So which numbers should I shade on these? -2 and -3. No.
لا -3 بس.
-3 only. Negative 3 only, not negative 2. Why? Because 2 and negative 2 are poles, and poles are never shaded. Never shaded. So I can never shade 2 or negative 2, even if they are with the zeros. Okay? So I have all these points. The next step is to find the signs. The next step is to find the signs of each interval of these. To find the signs, we choose a number here. For example, I choose 3, for example, and I look at every bracket. What is the sign of it? Okay, so each bracket, 3 and 3, this would be positive. Because I will never choose the number negative 2, I will also always choose points that are in between these numbers. So in this step I may cancel x plus 2 when finding the sign, because this will always be equal to this. So I can cancel this in just this step. Okay. What about x squared plus 1? What is its sign? This has a value that will always be positive. So for all the values, I may not check this bracket, because this bracket is always positive. Okay. Now for this bracket, 3 minus 2, that will be positive. So for this interval, that will be negative over negative, that will be positive. For a point between my negative 2 and 2, I will choose, for example, 0. When I choose 0, I will find that will be positive, that will be negative, and I cancel before these two, and that will always be positive. So I have the positive over negative, so that will be negative. Okay. For this interval, I choose minus 2.5. Minus 2.5, that will be positive. Minus 2.5 minus 2, that will be negative. That will be negative. Minus 2.5 minus 2, that will be negative, and that is positive, so that will be also be negative. For number less than negative 3, for example, minus 4, so that will be negative, that bracket will be negative, that bracket also be negative, so negative over negative will be positive. Okay. Now I will look now for the intervals which satisfy that is greater than or equal to 0. The equal sign, I just found its solution by the shading. Okay. So these shades are with me. Any shades are with me with the solution. Then I look for any interval for which it is greater than 0, which are positive signs. So I find this interval, and I will also find this interval. So what is the solution of this inequality, and which is exactly the domain? So the domain is just the solution of inequality. The solution of inequality, which will be from negative infinity to negative 3, open or closed? It will be closed, because minus 3 is shaded. Minus 3 is shaded, so negative 3 is with me. Union with 2 to infinity. 2 is open or closed?
Open.
This is open. Okay, and infinity is always open. Okay, so that is the solution of this this problem. If I had, for example, these points, and I had this one was shaded, and the positive signs were like this, positive and positive like this, what will be, or make it only that interval? If I'm looking for greater than or equal to 0, and that was positive with this, and all of this was negative, what will be the solution in this case? If that, for example, was negative 1, so it will be from negative infinity to negative 1. Closed or open? It will be open. Union with, should I take this number? For example, it was 0, so I will make it like this. Okay? So I look for the positive signs which solves the greater than part of the inequality, and the shading solves the equal part of the inequality. Okay, and we learned how to find the shades in the number line. We shade the zeros that are not common with poles. Any zeros, we shade them. If I have an equal sign, we shade the zeros unless they are with the poles. Okay, unless they are, for example, I had here -2, it is common with the pole, so I didn't shade -2 in this case. Okay, what do you expect if I made that simplification? If I tried to find the x plus 2, x plus 3 over x squared minus 4 root x squared plus 1. What do you expect for the, would the domain of this problem be equal to the domain of this problem? No. We learned that simplifications make changes in the domain. Okay, so in general, making any simplification changes the domain. How would I find the domain of such problem? We look at the restrictions and make the intersection between them. We look at the intersections, we look at the restrictions and make intersections between them. What do I mean by that? This is restriction number 1, which needs that what is inside that root would be greater than or equal to 0. That one should be greater than or equal to 0. And also we need that is the next restriction. We need that x squared minus 4 will be, what is the restriction on x squared minus 4 in this case? It should be greater than 0 or greater than or equal to 0?
Greater than 0.
Only greater than 0. I cannot put an equal sign because it is in the denominator. What about this part? We need here to, what is the restriction on this part? X squared. We need x squared plus 1 to be greater than or equal to 0. This is always positive. It is always greater than 0. So we may not put a restriction on this part. Okay? For any other expression, I would take that expression and put it greater than 0. But especially that expression, which is x squared plus 1, I know that this expression is always positive. So no problem to be inside the root. There is no problem to be inside the root. It doesn't make a restriction for me because we have known that any root should include only positive expressions, and these are the restrictions that we are making to find the domain. After solving this inequality we make the intersection between these two solutions, and that will be the domain of the problem. Okay, so that is just a reminder for the last lecture. Today we will study another function which is absolute value function. Absolute value function is a function which is denoted like this: y is equal to f of x equal to absolute x. When given some input, it gives the positive value of that input. What is meant by that? If I find absolute 3, it gives 3. If I give it absolute -3, it gives also 3. Okay? It gives also 3. As a physical meaning for this function, it just gives me the distance between a number and the 0 and the origin. Okay? So if I give you 4, what is the distance between 0 and 4? It is 4. What is the distance between -2 and 0?
2.
It will be 2. The distance is always positive. So what does the absolute value function mean? It means that we find the distance between x and origin. Okay? So we may express an absolute value function as follows. We say that given x, if x is positive, if the given x is positive, so the output will be exactly x. Okay, so the output will be exactly x. If the given x is negative, like -3, what will be the output? Would it be x also? No. X in this case is -3. So in this case, the output will be, it will be 3, which is, that is x. In this case, that is x. X is -3. And the output should be +3. So what is the output related to x in this case? It will be -x. Okay? So that is a definition, or a detailed definition of the absolute value function. For the value of 0, you can put it here or here, because it doesn't matter. For any given 0, given the input is 0, it will the output will be 0. Okay. Another form of absolute value function, we know that absolute x is √x². Now if I give you √4, what is the value of √4?
2.
Is it 2, or is it positive or -2?
Positive or negative? 2.
Yes, it is only 2. The square root gives me only one value, which is the positive value. It doesn't give me two values. We learned before that a function should have only one output for a given input. That is a known condition for any function. And the square root is a function. The square root is a function, so it has only one output. I cannot say the output will be plus or -2. But when would we say plus or -2? If I was solving an equation, if I told you solve the equation x² is equal to 4. If I told you solve that equation x² equal to 4, in this case x will be plus or minus √4. Remember that this has only a positive value, which will be 2. So in this case, the solutions of the equation will have two values. The two values are all expressed by the square root, a positive value and a negative value. But the square root itself has only one value. Okay? Now, if I told you I need to find the square root of x², square root of x², would that be x, or -x, or plus or minus x? X. For example, if I give you square root of 2², the result will be 2. What if I give you -2²? Square root of -2². That is 4, square root of 4, and that will be 2. So could I say that the result of absolute -2² is -2? Remember that this is x. That is x. So can I say that the output will be x?
-x.
In that case, it was -x, not x. So I cannot say it is x, and I cannot say it is -x, and surely I cannot say it is plus or minus, because it is a function and it will give me only one output. So surely I cannot say it is plus or minus. But what is the more accurate value is to say that the square root of x² is absolute x, because I have a square root in this case, so the output will always be positive. It is related, it will give me an x, but not x, it is x with its value, whatever was its sign. So that is exactly the absolute value of x. Okay? We need to know some rules in absolute value. For example, we know that absolute value of a multiplication is the absolute can be distributed on multiplication like this. Also on division, so it will be absolute A over absolute B. Another absolute A squared is just equal to absolute. Remember that this is A squared is a positive value. A squared is a positive value. When you take its absolute, would it make a change? No. So this is exactly A squared, and this is exactly also absolute A all squared. So it doesn't matter here the order of the operation. Are you making the square first or are you making the absolute first? Could I say this also for cubed or not? No. This is different. This is not equal to A cubed. Would it be equal to absolute A all cubed? Would it be equal to absolute A all cubed or not?
Yes.
No. This is also not equal to that. Why? If I had, for example, a negative value of A. If I had a negative value of A, for example, I had negative 2 all cubed, and I found the absolute. Oh, sorry, that will be, yes, that will be equal, yes. That will be equal. So negative 2 all cubed, that will be 8, negative 8, and all in the absolute, so that will be 8. So the result will be positive in this case, so that is correct. That is also correct, because the result will always be positive in this case. Another rule, which is that absolute A minus B, we can interchange the order of the difference inside the absolute. Why? Because absolute A is just equal to absolute negative A. Okay, it doesn't matter changing the sign of what is inside the absolute. So this case, that will be absolute AB minus A, and we always make use of this rule in, for example, if I had 2 minus x, a better expression is to express it to make the coefficient of x positive instead of negative. So it is better to use this expression instead of this one. Okay? An important rule here is to solve inequalities with absolute value of x. We have 4 main rules. First, if I have this inequality, absolute x less than a given number a. Now, I want to solve this inequality. For example, if I told you solve this inequality. What is meant by solving an inequality is to find all values of x which satisfy this inequality. I need to find all the x's that has an absolute value less than 2. Now remember, we need to find, this is 0, we need to find all the x's which has a distance with the origin less than 2. What are all these? Where are all these points, or what are all these x's? These are x's that satisfy this inequality, because each of these values has a distance with the origin less than 2. Okay? Are these the only x's that satisfy this inequality? No, we have also on the other side. On the other side, all these x's also has a distance to 0 or to the origin less than 2. So what is the solution of this inequality? They are all the values of x which are in between -2 and 2. Okay? And so let's make it as a rule. Absolute x less than a, it means that x is from -a to a. What about finding the solution of absolute x greater than a? For example, I need to find all the x's that has an absolute value greater than 2. What would be the solution in this case? Let's look on the number line. Where are the points that has a distance to the origin which is greater than 2? We have all these x's are satisfy this inequality. Are these and only x's? Where would you find other x's? On the other side also. Okay? So what is the solution of this inequality? It will be from, I would say that x is less than -2 union which is expressed as or x greater than 2. All of the x's, what is the solution of this inequality? Are the x's which satisfy x less than -2 or x greater than 2. Okay? As an inequality, we say it like this. So it is -infinity to -2 union with from 2 to infinity, which can be expressed as r difference, which interval would I exclude from r? -2 to 2, open or closed? In that case will be closed. Okay? In that case will be closed. I just need you to notice that this is just the complement of this. In this case, the solution was this interval. Okay? In that case, the solution was that purple interval. So these are complement cases. Okay? Not taking into account the value of 2, -2, or the boundaries of the intervals. We'll just take it out of our sight based on the inequality we are taking. Okay? So, for example, if I need to solve this inequality, absolute x greater than 5, what would be the solution? The solution will be x less than the negative union with or x greater than the value itself. Okay? One of them we just remove the absolute value, and the other we remove the absolute value but with a negative sign in this side, and you also change the order of the order of the inequality. Okay? What if I need to find the solution of absolute x less than 3? In the case of less than or equal to 3, the equal is reserved, so the solution will be x from -3 to 3 with the equal sign as it is. If I had an equal sign here, it will be also will have equal in these two. Okay? What if I told you I need to find the solution of absolute x greater than -3? Absolute x greater than -3. What are the solutions? What would be the solution of this inequality? Let's take for example first this case. When would be absolute x less than -3? We learned just before that x would be from the -2, so that will be +3 to -3. Is that correct? No, that is not correct. Why?
Absolute always positive.
I just applied the rule that I have just said, that absolute x less than a, so the solution will be x from -a to a. So if I had absolute x less than -3, if I applied this rule, it will be from -a, which is +3, and this will be -3. What about this solution? Is it correct? No. Why? So, and what would be the correct solution? Remember that this is an inequality. I'm trying to find all the values of x which make that statement correct. when would be an absolute value less than a negative? Remember that an absolute value has always a positive value or 0. It will take only a positive value or 0. Could a positive value or 0 be less than negative 3? Never. So what is the solution of this inequality? It is phi or no solution. What if I ask absolute x greater than or equal to negative 3?
No solution.
No, in that case it will be this is a positive value or 0. A positive value or 0. When would be a positive value or 0 greater than negative 3?
False.
Let's take this case first. Greater than negative 3. When is absolute x greater than a positive value or 0 greater than negative 3? When would that happen? For any value of x, this is positive, and this is so. This will be always correct for whatever was x. So in that case, what is the solution? It will be r. All the values are positive. All the values are solution. Put any value of x in this statement, and the statement will be correct. Okay. What if I ask absolute x greater than or equal negative 3? What would be the solution in this case? This is a positive value or 0. When would a positive value or 0 be greater than or equal to negative 3? The solution in this case is also R. Why? What if I told you, is this statement is 2 greater than or equal to negative 3 or not? This is true or false? What would you say? 2 greater than or equal to negative 3. That is a true statement or a false statement?
True.
You say that is true. You say?
False.
False. This is a true statement. This is a true statement. Okay? Why? This statement it just says that 2 is greater than negative 3 or 2 is equal to negative 3. I surely know that this statement is false. Okay? But this statement is true. Okay? When I have true or false, the true always wins. So that will be true. Because or, I'm just saying, is any of these true? Yes. One of these is true. If this true or this true, this statement, it just says, is this true or this true? Yes, one of them is true. So the statement is true. Okay, what is meant by or? I'm just asking, is this true or this true? Yes, one of them is true. So the statement, I can say that the statement is true. Okay, if I told you 2 greater than negative 3 and 2 is equal to negative 3, in this case I'm asking, is this true? Are both of them are true at the same time? No. In this case that statement will be false. If I ask you, if I put here the statement and instead of or. Okay, so the equal sign in this case doesn't matter or doesn't change the solution. So if I told you solve this inequality, absolute x negative minus 2 is less than 5. We just need to put a modification on this rule. We just state here that this a is a positive value. For this solution to be correct, we must state that this a is a positive value, and this is all for this statement also. Okay, so these solutions that we have mentioned are only in the case where A is a positive value. Whenever I have on the right hand side a negative value, we have in this case other solutions. It may be phi, it may be r, it may be other things based on the domain of and we'll see some examples on this case. If I told you solve absolute x minus 2 is less than or equal to 0, what is the solution of this inequality? An absolute is always positive or 0. Can it be less than 0? No. Could it be equal to 0? Yes. So what is the solution of this inequality? It will be x minus 2 equal to 0, which is x equal to 2. That is the solution. Okay? What about the solution of this inequality? Absolute less than a positive value. Okay, I will just apply the rule. X negative 2 is from negative 5 to 5. But I need to find the x by itself. So that will be, I just add plus 2 to all of the branches. So we'll have here negative 2 plus negative 5 plus 2 and 5 plus 2. So that will be negative 3 and that will be 7. So the solution will be from negative 3, 7. Okay? If I need to solve absolute 4 minus x less than greater than or equal to 2. In this case I'm having a positive value, so I just apply the rule for the greater than. Okay, but just before I solve the inequality, let's make this absolute with another expression which is better. X minus 4 greater than or equal to 2. Instead of dealing with this expression, it is just better to make the coefficient of x positive instead of negative like this. Okay, so we'll solve this inequality. That will be x minus 4. One of them is just remove the absolute value, or x minus 4, change the sign, then change the sign of the other value. We will solve these two and find the union between these two. So that will be x greater than 4 plus 2, which is 6, or x less than or equal to 4 minus 2, which is 2. Okay, let's depict that on the number line. Here is 6 and here is 2. Because we have an equal sign, we shade both 2 and 6. X greater than 6, so that will be like this. X less than 2, it will be like this. Okay, and in general, solving an inequality greater than, it just gives me on the number line something like this. We are just pointing outwards like this. Okay, but solving inequality with less than, it will always be an interval in between like this. Okay, that is in general for inequalities. What about this inequality? Root x minus 1 greater than or equal negative 1. We need to solve this inequality. Now remember that a square root is always positive. A square root is always positive. So that is a positive or zero value. Has a positive or zero value. When would be a positive or zero value greater than or equal negative 1? We just solved a similar one like this. When would be, yes, when would be a positive value or 0 greater than or equal negative 3? What was the solution? R. because I have here on a side a positive or 0, and I'm asking you when is this positive or 0 greater than a negative value. It is always greater than this negative value. Okay, this side is always greater than this side. Okay, so we had the solution to be R. What about in this case? We know that a square root, it's the output of a square root gives me a positive or a 0 value. So I'm asking you, when is this side that is positive or 0 greater than or equal to a negative value? It is always greater than. It is always greater than. Okay? So that will be, would I say that this will be R? The solution will be R? No. In this case, I cannot say it is R. Why? I just say that the solution of this inequality will be all allowed values of x. The solution of this inequality will be all allowed values of x. Okay? What are all the allowed values of x? We have learned this as a term. If I have a set that I collect in that set all the values that are allowed for x, this is called the domain. What is the domain of a function? The domain of a function is the set of all allowed values of x. Okay? So what is the solution of this inequalities? The solution is all the allowed values of x, which are the domain of this expression. What is the domain of this expression? Is x minus 1 must be greater than or equal to 0, which will be x greater than or equal to 1, and the solution of this inequality will just be from 1 to infinity. Okay? What if I asked you to find the solution of this inequality, x minus 2 less than or equal to negative 1? Would a positive value or 0 value ever be less than negative 1? Ever. That will never happen. So what is the solution is? No solution for this. That could never happen. A positive or a negative value, or a positive or a 0 value could never be less than a negative value. So that statement could never happen. So what is the solution? We say that there is no solution for this inequality. What if I ask x plus 2 less than or equal to 0?
X equal negative 2.
Yes, in this case x will be negative 2. What if I ask what is the great x plus 2 greater than or equal to 0?
Negative 2 infinity.
It will just be all allowed values of x, which are
negative 2 to infinity.
which are x plus 2 greater than or equal to 0, which is x greater than or equal to negative 2. What if I ask square root of x plus 2 greater than 0? When would that be greater than 0?
At x greater than negative 2.
X greater than negative 2. Should I put an equal sign here or not? No. I need to exclude the value for which the root would be equal to 0. Okay, I need to exclude the value for which the root is equal to 0. So that is the solution of this inequality. Now I need to remember that if I had root x plus 3 greater than negative 1, what was the solution of this inequality?
Root x plus 3 greater.
All allowed values of x, which are x plus 3 greater than or equal to 0, which x greater than negative 3. What about this solution? If I make squaring both sides, x plus 3 greater than or 1, or let's make this negative 2, so that will be 4. Is that an acceptable solution or not? It will give me x greater than 1. Is that an acceptable solution? No. This is a wrong solution. Why would that be a wrong solution? Couldn't I just square both sides in an inequality? No.
Different sides.
Squaring of both sides in inequality has restrictions. It is not allowed in general. Okay? Why? Because, for example, if I had, for example, we know that negative 3 is less than 1, for example. Negative 3 is less than 1. We know this statement is true. If I make squaring both sides, that will be 9, and that will be 1. Is this statement true? No. So that means that it is not allowed, it is not in general allowed to square both sides for an inequality. Okay? In general, it is not allowed to make squaring of both sides in an equality. Okay? What about this inequality? If I told you need to find x from negative 3, x minus 3 all squared less than or equal to 4. We need to solve this inequality. Let's first solve this inequality with this negative 1. What would be the solution in this case? That is a bracket squared. A bracket squared has a value which will be always positive or 0. Positive or 0. When would be a bracket which is positive or 0 less than negative 1? When would that happen? Never happens. That would never happen. Okay? So what is the solution of this inequality? It has no solution. It has no solution. And if I told you x negative 3 all squared greater than or equal to negative 1, what would be the solution? It will be all allowed values of x, which will be, in this case, it will be r. What if I asked for this inequality, x minus 3 all squared less than or equal to 4? Now in this case, this cannot be found by logic as these two. X negative 3 or x minus 3 all squared less than 4. In this case we have
taken square root.
Now remember we learned a method for any inequality like this. The method that we have learned, or the standard method that we have learned, we learned first some steps to take this to make it 0 in this side. So that will be x minus 3 all squared minus 4 less than or equal to 0. And make this as brackets. So I need to first to expand this and then to factorize it. So that will be x squared minus 6x plus 9 minus 4 like this. And that will be x squared minus 6x plus 5 like this. Then what we do, we would factorize this to do two brackets. I think that will be 5 and 1 like this. Okay, then on the number line we find the zeros and the poles with the systematic method that we have learned before. But for this expression we will learn another new method which will be easier and more quick than this standard method, which we will make use of the absolute value function. How? The second method is based on taking square root both sides. We just learned before that we cannot make squaring both sides. But could we make a square root both sides? Yes. We can make square root both sides. So that will be square root of x minus 3 all squared less than square root of 4. This side, square root of 4 is just 2 or plus or negative 2? 2. A square root has only one value. What about this square root of that bracket?
Absolute x minus 3.
Yes, this is, would it be x minus 3? No, it is absolute x minus 3. We just learned that square root of something squared is just absolute value of that what is inside the square. Okay, we learned this rule. So this inequality just converts to this one, which we have learned how to solve it. That will be x minus 3, and this is less than, so it will be from negative 2 to 2 like this. So that will be, the solution will be, I just add 3 to all of them, so that will be 1, and that will be 5 like this, and the solution will be from 1 to 5. Okay? So this method is applicable for if we had a positive value in this side and the left side was a bracket all squared. The left side was a bracket all squared. We can use this method which applies the absolute value function. Okay, let's check some other problems. For example, if I need to find the domain of this function, f of x equal to square root 4 minus absolute x plus 2. We have just learned how to deal with, or how to treat inequalities with absolute value. So to find the domain, we learned to find the domain. The problem converts to a problem of solving an inequality. So for this function, how to find the domain of this function? We just take that, look at the restriction, which will be 4 negative absolute x plus 2 must be greater than or equal to 0. So in this case, absolute x plus 2 will be, we can take that on the other side, so that will be less than or equal to 4.
Negative 4 to 4. Negative 4x plus 2x plus 2 to 4.
Yes, that is an absolute value less than, so we make use of the rule. So that will be from negative 4 to 4, which will give me x negative 2, so that will be negative 6, and that will be 2. So the solution will be negative 6 to 2. So that is the domain of the function. Okay? If I need to find the domain of this function, root of absolute 3 minus x, negative 3. Just the same procedure. We take what is inside the root, so that will be 3 minus x minus 3 greater than or equal to 0. I will just express it. I will just make the, yes, I'm interchanging, it will be x minus 3. That is better for treating that expression. And that will be greater than or equal to 3, which will be solved as x minus 3 greater than or equal to 3, or I just remove the absolute value sign, and that will be or x minus 3. I interchange this and change the sign of this. So that will be x greater than or equal to 6, or x less than or equal to 0. What will be, how would be that depicted on the number line? It was from 0, 6, and remember that it is greater than, so I am expecting that they will look outside like this, outward like this. Yes, it is x less than 0 and x greater than 6. Okay? What about this problem? F of x is square root of 3 minus square root x minus 2 all squared.
3 minus
Square root 3
absolute x minus 2.
Yes. We just here need to detect that expression. That is square root of something squared, which is exactly absolute of that, the absolute of that expression. So I need to find the domain of this function. So I'll just take what is inside the root. what is inside the root, and 3 minus absolute x minus 2 greater than or equal to 0. That means x minus 2, I'll just take it on to the other side, so that will be less than 3. So x minus 2 minus 3 to 3, so it is solved. Okay, what if I change it to be f of x to be 3 minus root x minus 2 whole squared?
3 name.
He requires you to find the domain of this function. How to find the domain? Now, would I make a cancellation or a simplification like this? Would I cancel the root with the square or not? Or would I say that this root x minus 2 all squared, is it equal to x minus 2 or is it equal to absolute x minus 2?
Equal to x minus 2.
This is x minus 2, but it is restricted with some domain. Okay, so I cannot say, when finding the domain, I cannot say either it is this or this. Okay, so how to solve this? I'm trying to find the domain. So when I'm trying to find the domain, I don't make any simplifications. Okay, so I'll just take it as it is. 3 minus root x minus 2 all squared greater than or equal to 0. So that will be root x minus 2 all squared greater than or equal to, less than, yes, less than 3. I need to solve this equation, this inequality. How would I solve this inequality? There is an obvious simplification here that the root will be, but when I make this simplification, I must remember that it is restricted, because I have here a square root. Okay, so I would make that simplification x minus 2 less than or equal to 3, but I will put the restriction that remember that x minus 2 should be greater than or equal to 0. Okay, when I made the simplification, okay, make your simplification, but don't miss the restriction that was on the expression on the first place. Okay, so I will solve this. That will be x less than 5 and at the same time x greater than or equal to 2. I will depict that on the number line. That will be 2, 5, x less than 5 greater than 2, so that will be from 2 to 5. Okay, maybe one could have solved this by just making the simplification and remember the restriction that was on the problem, on the domain of the problem. Okay, what about this function? Square root 3 plus root x squared. We need to find the domain of this problem. Root something squared is just equal to, yes, 3 absolute x. So what is the domain in this case? It is 3 plus root absolute x greater than or equal to 0. Absolute x greater than or equal to negative 3. What is the solution of this inequality?
R.
It is r. Or all the positive values of x, which is r in this case. So the domain will be equal to r. Let's check that problem. 1 over 4 plus root x minus 2. We need to find the domain of this problem. That will be, just take what is inside the root, 4 plus root x minus 2. We'll just make it greater than or equal to 0, or just greater than 0?
Just greater than.
Just greater than 0. So that will be x minus 2 greater than negative 4. When would that root be greater than negative 4?
What's it have restrictions?
All positive values of x. All positive values of x, which will be
2 to infinity.
x greater than or equal to 2. So that will be from 2 to infinity. That solution, which will be, I would have said r. No, it is not r, because not all values of x are allowed. So we just say that all allowed values of x. All allowed values of x, which is the domain of the left hand side. Okay. For this problem, f of x root 4 minus root x minus 2. Just treat it as usual. 4 minus root x minus 2 greater than or equal to 0, which means that x minus 2 less than or equal to 4. So what is the solution in this case? Could I make square both sides or not?
Yes.
Yes, in this case I could make squaring both sides. Why? I just told you before that we cannot always make squaring both sides on an inequality. But when it is allowed when both sides have the same sign. Okay? For example, if I had 1 and 3, 1 has the same sign as 3. They are both are positive. When I make squaring both sides, it will just be correct. Okay? If I had negative 3, I know that negative 3 is less than negative 1. Okay? If both are negative, that will be 9 and that will be 1. In that case, the inequality will be opposed like this. Okay, so we'll change the order. So if both are positive, we may square both sides. If both are negative, we may square both sides, but we interchange the inequality sign. If it was greater than, we make it less than. Okay? If they have different signs, for example, if I had negative 3 and this is 1, if they have different signs, I cannot determine. Okay? So whenever we have both sides are positive, it is allowed to make squaring both sides. So in this case, we'll make squaring both sides, which should be negative x minus 2 less than 16. But remember that you are trying to find the domain. So when we made the square, I need to preserve the initial domain or the original domain of the problem. So when I made that simplification, which is squaring, I need to say, and there is a restriction that was in the original problem, that x minus 2 must be greater than or equal to 0. I will solve this inequality, which will be x less than 18, and at the same time x greater than or equal to 2. So in that case, the solution will be 2 to 18. Okay? So that is for absolute value function. We will learn another property of functions, which is called symmetry in functions, or even and odd functions. We have two types of functions. A function which is symmetric about the y-axis, and that is called an even function. A function that is symmetric about the y-axis, as if there is a mirror, about the y-axis. In that case, this is called an even function. Okay? If I had a function which is like this, this function is called odd. What is an odd function? An odd function is symmetric about the origin. What is meant by about the origin? That if I had a point here like this, for example, if I made a straight line to the origin, I will just find another point on the other side just with the same distance like this. Okay? So any point like this, we'll just find another similar point on the other part, on the other side like this. Okay? This is called an odd function, which you call it symmetric about origin. Symmetric about the origin. This is symmetric about the y-axis. Okay? Now, for the odd function, we may see it as two reflections. An odd function, we can make a reflection like this, a reflection about the y-axis, then another reflection about the x-axis. So that will be like this. So if I make two constitutive reflections, one about the y-axis, then another about the x-axis, I will just get a function that is symmetric about the origin, or an odd function. Okay? Now that is the geometrical meaning of an even function or an odd function. How would I express that mathematically? We express that mathematically as f of negative x is equal to f of x. And we express the odd function mathematically that f of minus x is just negative f of x. Negative f of x. Okay? If a function that doesn't satisfy either this nor this, we call it a general function. So a function that is not even nor odd, a function that is neither even nor odd, we call it a general function. Okay? So let's check some functions. For example, x power 4. Is it an even function or an odd function? Or general? We just check the condition. How to check if a function is even or odd?
Negative x.
Yes, we check f of minus x. If f of minus x is just the same as f of x itself, so in this case it will be an even function. If it was minus f of x, then in this case it will be an odd function. If it is neither, it will be general. Okay, so that is f of x. So I will find f of negative x. What is meant by f of negative x? It means to substitute for every x with a negative x. So that will be negative x all power 4. What is negative x all power 4? It is just x power 4. Okay, it is just x power 4. So what is x power 4 related to the original function? Is it f of x itself, or is it minus f of x, or is it neither this or that?
f of x.
It is just exactly f of x. So in that case, f of minus x was just f of x. So in this case, we say that x power 4 is an even function. X power 4 is an even function. Okay? What about x power 3? What about x power 3? F of x is equal to x power 3. If I check this function, we'll find that f of minus x. That is, that standard method is to find f of minus x, which is minus x all power 3. Now we learned that minus x, that will be negative x power 3. And that is exactly minus, yes, f of x itself. So in that case, we deduce that this function is odd function. What about the square root function? We just check f of minus x, which is root minus x. Now, could I take that negative outside the root? No. So it is neither root x nor it is negative root x. So we say that root x is a general function. It is a general function. And that is obvious from the graph of the function. We learned that the graph of the function of square root is just like this. An odd function or an even function must have a branch of the function which is in the negative side. Either it is a reflection of about the y-axis, or it is a reflection about the origin. But in this case, this function, its domain is not symmetric. Its domain, there is no negative part in the domain of this function. So just from the graph of this function, we will know that it is general. Okay, it is obvious that it is general. For any power function x power n, can we make a general rule for even and odd functions? Yes. This is f of x. F of minus x is just equal to negative x all power n. And we learned that from the rules of exponents, that will be n minus 1 power n, x power n. Which means that f of minus x will be negative 1 power n times f of x. This means that for n even, negative 1 power n, which will just exactly be f of x itself. So that will mean that in this case, f of x will be an even function. For the case of n odd, the result will be negative 1 power odd will be negative f of x. So that will mean f of x in this case will be an odd function. So we just learned a rule that for a power function, if the exponent, if the power is even, then the function itself is even. And if the power is odd, then the function itself is odd. Okay? So this is a rule. Now we will learn some rules for dealing with more than two functions or more. For example, for addition or subtraction. Addition or subtraction. If I had an even function plus or minus an even function, the result will be an even function. Okay? Remember that we are dealing here with even and odd functions, not numbers. There is a difference between an odd function and an odd number. Okay? Just before we proceed, if f of x is equal to 3, this is an even function or odd function?
Even.
This is an even function. This is a constant. Okay? This is a constant. A function constant. It is obvious that it is symmetric about the y-axis. And this can be considered at x power 0. X power 0 and 0 is even. 0 is even, so it is an even function. Okay? So any constant is an even function. Any constant by itself is an even function. Okay? Odd plus or minus odd function, it will give me an odd function. Even plus or minus an odd function, that will give me a general function. Okay? So for example, if I had 1 plus x squared, 1 is even or odd?
Even.
1 is a constant, so it is even. 1 is a constant, so it is even. Remember, make a difference between an even function and an even number. Okay, it is an odd number, but it is an even function. Okay, this is an even function because the power is even. Even plus even will be an even function. Okay, if I told you x plus x power 4, that will be, that is odd. That is odd function, and that is even function, so the addition will be general. Yes. And so on. Just before addition and subtraction, remember that multiplying by a number doesn't change the multiplication with the number. Multiplication by scalar or by number does not change kind. What is meant by that? For example, if I had x power 4, if I multiply it by 3, that function will also be even. We have learned that this is even. Okay, what about 3 times x power 4? It will also be even. What if I multiply it by a negative minus 2x power 4? Would that be? That will be also even. Okay, negative 3 times x power 5. That will be odd. I don't look at, or it doesn't matter what scalar it is or what number it is multiplied by the function. Okay, it doesn't change the kind. What about multiplication and division? Multiplication and division between functions. Multiplication and division between functions. We learned that even times even is odd times odd is odd times even is. To learn how to find the result of an even times even or odd times odd, all of these cases is just summarized by a simple rule. Deal even as positive and deal odd as negative. Okay? So if I have an even function as if it is positive. Positive times positive will be positive, which is even. Odd is negative. Negative times negative will be even, which is positive. Okay? Odd times even, which is negative, which is odd. Okay? And so on. For any combination of multiplications and divisions, we can make this similar rule. If I had odd function times even over odd times even. So that function will be even or odd? Negative, positive, negative, positive. That will be negative, which is odd. Okay? So that is the rule for multiplication and division. The last rule is for the composition of functions. Composition of function. What is meant by composition of functions? If I have some function f of x and a function g of x, if I say I need to find f of g of x, if I put a function inside another function. Okay? For example, if I had f of x is equal to x squared, this can also be denoted as f of g, f of g of x, f of g of x. Okay? F of g of x. If I had, for example, f of x is equal to x squared and g of x is equal to 2x plus 1. What is f of g of x? F of g of x. What is f of g of x? It means that to take every x in f, take every x in f and put 2x plus 1 inside. So that will be 2x plus 1 all squared. Okay? So this is a composed function. This is the insider function and this is the outsider function, which is squared. If I need to find g of f of x, g of f of x, what would that be? It means that inside g, take every x and put f of x instead of x. So that will be 2x squared plus 1. Okay? And in general, f of g of x is not equal to g of f of x. Okay? Now, in this case, we have two main rules. If f of g of x for the composition of functions, if g of x is odd, let's take first, if g of x is even, then f of g of x will be even, whatever was f. What is meant by that? For example, if I had x x cubed plus x power 4, if I had root x power 4 plus x squared, this is a function inside another function. This is a function inside the root. Okay? So I may see this function as a root. The outsider function is f. And the insider function is this function. What is this function? Is it even or odd? That function? It is even plus even, which will be even. So that insider function is even. So I need to know root of even function. I just told you the rule that if the insider function is even, then the result will be even whatever was the outsider function. The outsider function here is general. The square root is a general function. So whatever was the outsider function, the result will always be even. Okay? If the insider function is even. Okay? What about if the insider function is odd? If the insider function, if g of x is odd, in this case, f of g of x will be as f. It will be as f. So, for example, if I had x cubed plus x, in this case, the insider function is odd. So I need to know what is square root of odd. I just told you the rule that if the insider function is odd, then the composition of the functions will be as f. F is the outsider function. So that is as the root function. The root function is even or odd?
General.
It is general, yes. This is general. So this function will also be general. This function will also be general. If I had x cubed plus x all power 4, This is the insider function. The insider function is odd. So I have here odd power 4. The outsider function is power 4. What is the function power 4 is? It is odd or even? It is even. We have learned that this is even. So because the insider function is odd, so the kind of the function is as the outsider. The outsider is even, so the function will be even. Okay? What if the insider is general, if this is general, so we have no rule in this case. No rule in this case, and in this case we'll just need to check the standard method. In this case we'll just check by the standard method. Okay? You can check the proofs of these rules in the lecture. They are obvious, but what you need to know is how to apply these rules on different problems. Okay? You can find other problems in the sheet.